for having me. Let me share my screen here. I have dual screens, so I want to make sure I share the right one. I'm a civil engineer, but I'm definitely an atypical civil engineer. I'm assuming that most of you, like me, when I was younger, had no idea what civil engineers did until I started working for one company in my early 20s. So with that, I'm going to discuss civil engineering for you as a consumer of civil engineering, how the phrase civil engineering came to be, that label to the profession, examples in our daily life of work from civil engineers, and typical project evolution. And then as an advocate for civil engineers, because I understand most of you are teachers, a message to your students about the potential for becoming an engineer and what they do, how to cooperate with civil engineers, which are technically civil servants, in your community to help you. And if you'd like to know more about not only your community, but our work, I have some resources that you may be interested in. Keep in mind, as I mentioned earlier, I'm an atypical civil engineer. I did not simply go to college right after high school and decide that this is what I was going to do. So it's important to keep in mind as we go through the presentation that I changed as I knew better. I tried to do better. And that's a quote from one of my favorite authors, Maya Angelou. A little bit about my background. I grew up in Colorado and went to a business college there. Many years later, I attended UCF and got my civil engineering degree. It did take me a decade to get it. And I finished in May of 2010 when I was 40. Prior to that, as you'll see in a moment, my work was with civil engineers was administrative. Once I always kind of did civil engineering because it was a well-paying position, but I always loved nature. I had a lot of pets when I was younger, and my connection to the natural world, once my children were grown, I decided to focus on, and that's when I got started to pursue my my master's in biology. At the time I began the pursuit, I didn't know if I would find an intersection between civil engineering and biology, but I kept my options open. At the time before I got my engineering degree, I was controller of an engineering firm. I was responsible for all business aspects of its operation. The only thing I didn't do was create plans, but comprehensive responsibility for contracts and money, hiring, firing, all of that. And it was sort of, it inspired me to get my degree because there is a cap when it comes to engineers' respect. In general, most civil engineers respect other engineers. And if you don't have a degree in engineering, there's a limit to responsibility and compensation. I actually entertained the idea of leaving the profession and did sales for a little while in the Southeast USA. I sold industrial grade communications equipment to customers in Mississippi, Alabama, Georgia, and Florida. It also paid well, but it certainly had no connection to the natural world. I eventually had a master's project that connected me with my current boss. And I'm a project engineer now at DRMP. We're a multidisciplined civil engineering firm. My project path has included, since graduation, I've worked and lived in California, Colorado, Pennsylvania, Texas, and I'm in the Orlando area right now. Some of the projects that I've worked on have been rail yards, airports, roads, and my focus now, to blend between civil engineering and my master's, has been to consider the ecosystem impact of infrastructure, and I work on stormwater projects. Most of the projects are on the periphery of urban life, where the consideration of wetlands, water quality, and endangered species come into play. I also did volunteer work while I was at UCF. We had a water project in Haiti. I worked with Engineers Without Borders and have been to Haiti twice. And then my ongoing volunteer efforts with the Florida Native Plant Society keep me busy. I kind of decided, as much time as I'd spent learning about mammals and not enough time spent on learning about plants and birds. So that was part of my outside work interest, has to do with learning about the ecosystem as a whole. So that's how my volunteer work rounds out everything. Now, as far as the etymology of civil engineering, at one time, engineer meant someone who created weapons of war. If you ever look up medieval devices, there were some really creative ways to attack your opponent, and engineer, if you describe someone that way, that's what they did. So civil engineer, as in civilization, differentiated an engineer from someone who created weapons of war to someone who did technical work to improve our daily lives, of which water is one of those. Now, the water spigot here, part of the reason I included that image was so I could talk about the Broad Street pump. It was associated with the 1854 cholera outbreak in London. And John Snow was a civil engineer who removed the handle from that pump when he determined that contaminated water was the source of the cholera outbreak. And really, in 150 years, unfortunately, some things remain the same. It took John Snow 7 years of politicking to convince the powers that be to build the London sewer system, because they thought cholera was caused by odor from fecal matter instead of bacteria from fecal matter. So the challenge for engineers to get politicians to embrace actual science remains. It's nothing new. Some examples in our daily life of civil engineering work that touches you is when you drive your car just about anywhere, there's bridges and roads. You know, project like this one is hundreds of millions of dollars in several years. Here's a dam and also a wastewater treatment plant. They also fit that description, multi-year projects that have hundreds of engineers and calculations and software and hardware and construction efforts all put into them. Those big projects are great, but there's a lot of engineers like me whose projects touch you more personally. A good portion of the work I do right now has to do with fixing drainage problems for communities that shouldn't have been built in a floodplain altogether. And it's a challenge when you have to consider not only elevations, but soil type and places for that water to go. You need to consider the quality of that runoff water and whether or not it needs to be treated before it is discharged into, you know, some pond. Sometimes communities require a pond be constructed just so that on that 1 in 100 year storm, that the water has some place to go other than your home or business. So those are some examples of civil engineering products that we all as a civilized community benefit from. And, you know, infrastructure connects us, and it's the buildings where we live and work. They, you know, provides a basis for personal security and public health, and impacts economic viability and the competitiveness of our cities. And I'd like to share a video with you next. This is, I hope this plays as expected. I have not been a presenter where I played a video, so I'll be watching to see if I have any feedback about lack of sound or anything. But this video is just 2 minutes, and it kind of gives an overview of Envision. And if, I don't know if you remember in my name, I have a suffix that's ENVSP, and that's associated with this set of principles and design. So let me see if I can play this. I hope you enjoyed that overview. There were a few things I meant to mention before starting the video that I want to include now before I move on. In general, civil engineers need to complete 4 years of school at an ABET accredited institution. And the capstone of that education is taking the fundamentals of engineering exam. It's sort of 4 years of college in an 8-hour exam. And that is what that designation EI after my name is for. I passed that exam in 2013. Once you pass that exam, you need to work underneath a licensed professional engineer for 4 years before you can sit for the next one. And the next one for that professional engineering exam is essentially an 8-hour pencil and paper exam for 4 years of professional work. And once I just actually sat for that exam a couple of weeks ago, so hopefully I will change the suffix from EI to PE. I won't know till Christmas though. And most states, when you're licensed as a professional engineer, they recognize that designation from state to state. The only exception is California, where they appreciate the fact that you sat for one 8-hour exam, but if you want to call yourself a PE in California, in addition to that exam, you have to sit for a seismic and survey exam as well. Those are 2 separate exams, but you have to pass all 3 in order to call yourself a professional engineer in California. So that's kind of the gold standard. So the project evolution of a typical civil engineering project begins with a public advertisement to engineering teams that describes the scope of work, what it is that needs to be done, whether it's the redesign of something, new design, studies, etc. And those advertisements are usually in the hard copy of your newspapers. They're usually fine print that, unless you're an engineer, you just glance over. This is where too later we'll talk about advocacy and the way that you can maybe look at those details in a different light. But anyway, the design process starts once a city or county or the state, sometimes federal, make that project team selection and design begins. And then construction. And with some projects, there's more than one delivery method, which the typical delivery method is you design a project and then you build it and then you maintain it. But in order to expedite the process, many clients, both public and private, have combined the design and construction aspects into one effort, where instead of the contractor and the designer almost being at odds the entire time, the designer telling them, you know, you bid it, you build it, just like I said, like I designed, and the contractor saying you designed something that's impossible or expensive. Instead, the client puts them both on the same side of the table, and that's what's called design build. And that way, they can work together on a solution. They can minimize costs. The drawback, though, with design build frequently is that because it's not designed completely yet, and effort is very nebulous, there isn't usually a price. That instead of that advertisement saying we have X million dollars to spend on this effort, a design build, you don't have a price tag because it's not designed yet. You can have a ballpark, but it does facilitate a faster project delivery and maybe some efficiencies that the typical project delivery doesn't allow, but it is actually more and more common. So design and construction, especially if it's a very large project, sometimes happens simultaneously with some of the design work being constructed very shortly after being designed, and that continues for the life of the project. Maintenance is an aspect of our work that is so important. Unfortunately, it is not very sexy when it comes to public officials supporting it. It's hard to believe that infrastructure doesn't last forever. Most people would be actually amazed at how old the water pipes are that service your home and communities. You know, the problems that happened in Flint, Michigan are actually not unique. The investment needs to be made in upgrading very, very old infrastructure to prevent those kinds of tragedies from happening. The same applies to bridges and roads. Typically, for instance, a bridge deck that is usually made of concrete, just the deck of it will last between 15 and 20 years. And then it needs to be redone. And roads, a typical asphalt layer, typically lasts about 10 years. And then you end up with potholes and cracks and undrivable conditions shortly thereafter. Sometimes if the surface that the road was put on was not prepared correctly, sometimes potholes and those kinds of problems happen long before the failure of the pavement that is on top of it. So this is where having to pay attention to feedback and your clients about what it is the end goal is so important. So demolition is also an aspect of civil engineering that is inevitable. Sometimes you can't maintain and repair something that needs to be replaced altogether. There's many bridges that you may have heard the term structurally deficient. And that might be that the bridge might be sound, but you can't, for instance, add another lane. So it still needs to be raised and replaced. And this process continues. So that's where civil engineering is pretty, I don't know, safe is probably not the right word, but it's certainly a profession that there's not an end date on. It's usually pretty, I guess when it comes to our economics is concerned, recession proof. For those of you who teach and have students who may be interested in becoming a problem solver, the most important message to them, I hope that you'll share, is to never give up. About 60% of the students who begin an engineering degree in college do exactly that. They give up. More of those who switch their major are actually men than women, but women are a very, very small minority in the profession. So when it comes to never giving up, it requires some independence and persistence, because there'll probably be times where that support network for less challenging career pursuits, your classmates might have that, but it takes true tenacity. I know personally, one of the misnomers when it comes to selecting civil engineering as a profession is that everybody says that people are good at math. And actually, civil engineers are more problem solvers than mathematicians. We're more about setting up the equation and somebody takes it from there. So it's more about problem solving. I mean, and truth be told, I absolutely hated Calculus 3 and differential equations. They're required, so I got through them, but it was not a joy. And so, you know, as long as you've got tenacity, you can get through that, and there's rewards on the other side. The other thing that they need to know is that you need to be flexible. As I kind of explained the tapestry of my career path, especially now more than ever, as you saw the Envision video, there's great opportunities for people who want to do interdisciplinary work. Actually, engineers need to they need to talk to chemists and botanists and ecologists and biologists and social workers and English teachers and more in order to communicate and execute these projects that touch all of our lives and minimize that impact on the natural world. So there's plenty of opportunities within civil engineering, or I should say there's more now than ever when you're actually not an engineer, but definitely are needed and can contribute to a successful project in a different profession. So as far as cooperating with civil engineers, part of the reason I picked this image is it was as close as I could find as someone attending a public meeting. Just like those advertisements, you know, that designing a road takes time, and constructing it takes even more time. So it needs to be clear as a consumer of civil engineering products, the timeline associated with them. Oftentimes, when you're unaware of what the project life cycle is, when you first see a bulldozer, that's, if you haven't been paying attention, that might be the first time you notice that they're making a change to your community that maybe you don't want. But at that point, once the bulldozer's there, there's very little chance to impact what that project is. That's why it's really helpful to pay attention to public meetings and to those advertisements and ask questions and provide input early on in the project life cycle so that we can accommodate that the best that we can. By the time a bulldozer is out there, it's just simply too late. So, you know, I hope as a consumer, you'll consider paying attention to some of those things. And, you know, the other thing that's really important is to vote. You need to vote for elected officials that support investment in infrastructure. And they support investment in the maintenance components of infrastructure and not just simply building a new road or bridge that will have a label with their name on it, especially maintenance. It really, I can't stress enough how unimportant a new bridge is when the community it connects to doesn't have clean water. So when you vote, make sure you ask questions and make sure those elected officials know how important investment in infrastructure is, because it, you know, every time you get a glass of water or pull out of your driveway, you're in the design. Another thing that you can do, Envision principles that consider infrastructure as from a holistic standpoint. That you may be familiar with LEED criteria for buildings. For energy efficiency, a building can earn points and get, you may have heard LEED is L-E-E-D, all caps, and it stands for Leader in Energy Efficiency and Design, I think. And it's essentially for vertical projects for buildings. Envision has those. It has similar criteria, but it's for horizontal projects. So each project can earn a certain amount of points and get that label of gold or platinum or silver. And as a community, ask the question at those public meetings, can you incorporate or require Envision principles in infrastructure projects that come through for your vote as a councilman or a chairperson, or have it, you know, some peripherally, you know, some kind of influence on? Ask them about Envision principles and how they feel about them. And if they've never heard of them, connect them with an engineer who can explain them, because it's very important going forward to establish projects that are resilient, that last a long time, and also meet all the goals of the community. So Here's some resources. They're kind of Florida specific, since I understood that was the audience mostly here was Florida participants. The last one there for the our I-4 Ultimate project that has redone the 21 miles between Orlando and Tampa, that stretch of I-4. There were some surprisingly, it's aggravating being a local and having to navigate construction codes and different paths as construction proceeded. There were a number of things about that project that were actually very green, like the amount of recycled concrete and what they did with some of the work materials as the work took place. And I hope you'll check out that link and learn more about that. Some of those meetings that I recommended that you tune into, especially now with COVID, so much has become virtual. So in a good way, you really just making time on your schedule instead of having to travel and park. Those meetings are more accessible than ever. And learning about the process is also helpful, even if you're not a civil engineer, just learning how to be a good citizen and community, a contributor to your community. Orange County and City of Orlando have options for you to get involved that way as well. So I hope you'll find me on LinkedIn and connect if you'd like to know more. And I look forward to your questions.
Wonderful, thank you so much, Anna. And in a funny twist, I actually did, in an email to some teachers, I linked to your LinkedIn profile because it was the best version of the information available to me.
Oh, good.
So yeah, we do have some questions. First, I guess, I don't know if you could provide us with some good examples of impacts, sort of like, what would life look like without civil engineers?
Well, actually, that's actually sort of an easy question to answer, because the level of service that we enjoy in the United States is atypical. If you want to see what life with no civil engineering or minimal is, go to Haiti. You'll come back and you'll be on our freeway and you will consider it a ribbon of glass. You want to know what the struggle would be to try to find a glass of water that you're not going to get sick from? That's the reality. And that's where too, at least in our recent election, one thing that engineers factor into their designs is something called economy of scale. Basically, if you think about like a computer, no matter what kind of computer you have to have a motherboard, and then you stick stuff on it, and that changes the price and the capacity and everything. But there's a baseline that you've got to get to before you can do more stuff. And essentially, that's where economy of scale, there's a certain amount of money you have to spend no matter what you're going to do before you can get fancier. And the thing is that economy of scale, it's just simply less expensive to do things on a larger scale. So this is why we have water treatment centers that service entire communities. And we don't have people building a private road that's only 1,000 feet in front of their house. You have to invest in those projects on a larger scale in order for them to happen. Some people consider that cooperation and community investment. Unfortunately, it gets labeled as socialism. But that's where part of the reason the United States enjoys the civil engineering products that it does is because we share the cost as a group and put the best ideas into play and recognize the benefits of economy of scale.
Wonderful, thank you. So I guess, I mean, since you all live in Florida. I don't know if you could speak to like building on ground that is full of like pockets of water and aquifers. And especially when you start talking about when we're, pulling up fresh water from the ground as well.
Well, one of the challenges we have in Florida is we have a very high water table.
Yeah.
And most of our, we're a peninsula that's mostly sandstone and limestone, and it's very porous. So there aren't a lot of basements in Florida. And when it comes to our springs and our water sources, a lot of them are closer to the surface. This is where a sort of a partner discipline within civil engineering is called geotechnical engineering. And it's an absolutely essential part. I should have actually probably included a bullet for that, because before you can start designing foundations and runoff and all of those things, you have to have solid geotechnical information. They go out there and take soil cores and they take them back to the lab and they test how porous that and how many different kinds of soil are in play. And decisions are made about how deep to make the foundation or where to place it based on the layers of rock. If you've ever been to, for instance, like the Grand Canyon, and you can see the strata in the stone, essentially soil has the same kind of multiple components. And the deeper you go, there's all kinds of different things that you discover when you take a very deep core. In Florida, there's, I guess, I've done most of my work here when it comes to geotechnical stuff. So I'm not, there's something called muck. And essentially muck is, in 100 million years, it would be oil. It's dead vegetation that's been there for hundreds of years, and it's not stable. You can't build anything on it. So if you have a project where you encounter muck, the only solution for the client, whether it's a private or a public client, is you have to remove it and replace it with clean fill that you can actually depend on, that would, support a foundation. And there are some projects in Florida, some places, I should say, in Florida, which will never have a project on them because underneath 10 or 15 feet of soil, beneath that are dozens of feet of muck that in order to build something, you'd have to remove in order to work with. And it gets very expensive to remove all that soil. And sometimes it works out for the better. For instance, my work with Florida Native Plant Society, one of the locations that we do our work at is called Mead Botanical Garden. It is a 50-acre location that is in the center of the urban universe. It's bounded on all sides by heavy development. The reason it's not been developed is because that scenario I described is exactly that. A developer would have to remove 40 feet of muck and replace it with clean fill dirt before they could even get started. So they're not going to spend, 30, 40, $50 million doing that only so that they can sell a few $1 million homes. It's just not economically viable. So the good news for that location is that it has rich biodiversity. It's been left alone. There's gopher tortoises that live there and hundreds of species of birds that, people who are into birding and bird watching and the Audubon Society, Mead Botanical Gardens is a destination because there's so many different kinds to see and thrive there. So yeah, Florida, I think actually the most challenging animal in Florida to work around is the Homo sapiens, because our government, unfortunately, as I mentioned earlier with John Snow's work way back in the UK, and early when I was describing my work life, there are unfortunately too many politicians that don't look long-term and sometimes approve development projects in places where there should not be homes in the first place. And long after they've walked away and people are living there, and you get a storm, and it's like, how did I end up with 2 feet of water in my living room? And we end up having to address that after the fact, after the developer's long gone.
Thank you. And then sort of a quick follow-up question. Is Miami actually sinking?
Well, saltwater intrusion is a problem. So it's not so much a change in elevation, it's of the land. It's a change in elevation of the sea. Sea level rise is real. And in Miami, they have some very complicated solutions, and they're different from the inland ones that I usually work on. The sea level ones where they're trying to essentially keep the ocean out of someone's front door is a whole nother specialty of its own. So Miami has permanent pumps installed in some locations, and they fight it every day on a dry day. So there is a whole cottage industry of insurance here in Florida where one of the questions the agent asks the customer is, how long do you want to enjoy this structure? 10, 15 years, 20? And it depends on the answer to that question, how they recommend it be designed. Because if it's a very long-term one, it'll probably be on stilts that are literally 20 feet high. If you don't care if it gets flooded after 10 years because you're going to be dead, you can make it a little bit shorter. But it's certainly, when it comes to paying attention to science, the insurance companies are, surprisingly. And it's a real consideration for people who own real estate here to keep in mind. Sea level rise affects Miami, but there are other water issues that still affect those places unrelated to sea level rise when it comes to water quality and the challenges we have with Lake Okeechobee and eutrophication, which has to do with the algae blooms and fish kills and things like that.
Awesome, thank you. So we're gonna wrap it up. And I actually would very much like to actually sit here and ask you start asking some questions about, say, like the Everglades and how, some of that building is really affecting water in Florida, but that's a whole other side topic, obviously. So to wrap up, I want to thank everyone for joining us today. I want to thank our 2 presenters, Dr. Rebecca Rogers and Anna Pepper, and especially Anna Pepper for coming in last minute when our speaker was apparently suddenly became unavailable to us. So phenomenal. Thank you so much for joining us. And I have to say, I've seen a lot of civil engineering presentations, and this is a really fun, different angle. So I very much enjoyed it.